Welcome to Chapter 6, Part 1. We are starting to talk about functions, which is going to be really useful when you are programming your game. So we've played a little bit with built-in functions up to this point, right? Spider, robot, distance, things like that. But we're going to be writing our own. So as you know from math, so a function receives a value, you have this input stuff, the function does stuff, and it produces an output. I always think of this as the black box. We don't exactly know always what's going on in there, but you put stuff in and you get stuff out. And what you return as far as programming depends on what you're putting in. So it could be a function for a number, an object, a color, a true, false, etc. So here's a new example in case you were ready to be done with the robots and the snow people. So we're going to talk about bouncing a ball, and we're going to talk about putting a ball over the net. So Paige, this one's for you. We're going to say that the ball has been positioned 1 meter from the net, and the ball's going to go up and forward and then down, something in a pattern that looks like that. Okay, not very complicated, or so you think. So what I want you to do is I want you to try and do this. It shouldn't take long to program, but I want you to open Alice, open the textbook world called this, and write the code to make the ball bounce over it, meaning it has to go up and over and then come down. So there's actually no bouncing involved. It's kind of a fake word. So pause the movie and give it a shot. Okay, so this is version 1 of it, and if you go to this method, it seems like this should work, right? The toy ball turns to face the net, and it moves up, goes forward, and goes down and forward. Not that hard, right? But watch what happens when I play it. Oh dear, that's a problem. How did yours work out? Did yours do a better job? Well, let's talk about some ways that we can improve that. So here's the answer, or here are some of them. Turn to face the net. Why? Because we need to have it face the net, but we have to figure out how we want it to face the net. And also how much to go up. We can use a built-in function for that. So here's a design for a method. Turn to face the net, go up, go forward, go down, go forward. So you saw that, but there's a subtle little trick that I want to show you. Okay, so the code looks like maybe it's really similar. Let's see how it plays. And then it goes over. All right, so what was different? Believe it or not, just this one line right here, the orient to the tennis net. So now that it's oriented, when it turned to face it, and that's what's kind of interesting is figuring out what was the face part. So watch again. For this toy ball, the face part is that star. And so that's what it was. And when it was lying on its side and it was trying to point towards the net, it got really confused and had a hard time. So one more time, because this is pretty amazing. So orient to the net, turn and face the net, and then up it goes. Okay, so that one line, and if you take out, just to show you one more time, if you take out that one line, then it doesn't work very well, does it? That's kind of a disaster. Okay. Oh yes, one more thing that is a little bit different is how much it moved up. Before we had it just moving up a meter. Now it's moving up the height of the tennis net. So this is under tennis net, under function, and if you go down, it's height. And this really isn't new information because we've been dealing with it with width and half width and stuff like that. So just another little subtlety as part of it. So what you saw in this example was I just showed you the built-in height function, and that was just enough to clear the net. So that's a nice little subtlety. And we talked about the orient to movement because who knew which way that the ball thought was up? Not always easy to say. So now we're going to try something. We're going to roll the ball along the ground. And we want something realistic, not just a slide. So it's got to simultaneously move and roll. If you could, pause the movie and go roll something, whether it's a ball or, I don't know, something cylindrical, maybe a toilet paper roll. Just go roll something and really take a look at how it moves and what that's all about. And when you come back, I'll be here for you. Okay, so now that you've seen it in real life, I want you to give it a shot and go ahead and program using the textbook example ball roll. Come back when you're done. Okay, so here's the first version of this, and so the code says move it forward and turn it forward, and you're doing it together, so that should be all fabulous, right? Did this happen to you when you tried to create it? It's kind of funny, but it's not all that useful. So how do you make it roll? Great question. Okay, so the problem was that our design assumed that the ball's motion was relative to the ground, but the ball was turning relative to its own sense of direction. So again, picture, it was all relative to its own center. So What's the solution? Let's take a look at it. Let's look at it relative to something else. Okay, so let me show you how it works. That looks much better, right? Looks like it's rolling. And so what was different is that it moved forward as seen by the ground. So we were assuming that was true before, but it really was not. Okay, well that's great. Now what we want to do is we want it to roll a certain distance, and we're going to put in, this is our first function that we are creating. Okay, so now that we figured out how to roll it, let's have it roll one revolution, but we want it to roll a certain distance along the ground. So think about it. How many times should the ball turn one complete revolution? What does it depend on? As you think about it, think about the size of the balls. If you were rolling a bowling ball versus a ping pong ball and you wanted both of them to go 3 meters, how would their motion look different? What would be different about how many times the ping pong ball rolled versus how many times the bowling ball rolled? So, as you might have figured out, it depends on the size of the ball. So to go the same distance, the number of revolutions is dependent on the size of the ball. It's actually dependent on the circumference. Because if you think about it, that's the circumference right there. Hopefully you can see that little motion. And if you roll it once, that's also the distance it will go. If you don't believe me, find a ball and measure and see if that's true. So the number, if you take 1 revolution times pi times the diameter, because that's how you find circumference, right? That'll be a certain distance. If you want to figure out how many revolutions you go, you take that distance divided by the quantity pi times the diameter. So there's no built-in function to return the number of revolutions, but that's okay. We're going to write our own. And we're going to use parameters. It's very exciting. So we want to return the value computed as distance over pi times diameter. As I said, that's the number of revolutions. So what do we need to figure out? Think about it. We want to figure out the ball's diameter. How do we find that? Well, it has a built-in width function, so the width is the diameter. That's easy enough. And we need to figure out the distance the ball is to travel, and that can be sent in as a parameter. Okay, so here we go. Ready? You're going to make a function. It's lots of fun. I want you to go back and click on the ball, and so we're going to have a class level function, an object level function. Sorry, that should say object level function. Click on functions, click on create new function, name it, make sure it's lowercase, choose what type. I would recommend number because you're trying to get distance. Click OK, and you'll see return 1. Okay, after you've done that, so if you haven't done that, stop and go back and replay that really quickly. Now we're going to use a parameter. For what? For the different distances. So click on the arrow next to the 1, and that's going to make your math function expression. Finish off the function, and now you're going to create a method where the function is called. So pause and give it a shot, and then I'm going to show you the answer. Okay, I want to show you how it works, and then I want to show you how to create it. It's actually very exciting. I don't know why I'm yawning. Okay, let's watch how it rolls. Okay, so it doesn't look that different. What happened is that you had it move forward 3 meters, and it turned the right number of revolutions, where the number of revolutions was connected by the distance 3, and it's the same duration, which you want to pay attention to because that's useful. Okay, so where would you find this function? Well, I clicked on toy ball, and this is the function that was already created, and so it looks like that. What I want to show you is how to do that. So let's do create new function. I'm just going to make it up, so let's call it numRev, and it's going to return a number because it's going to actually return the number of revolutions, right? So we're going to do that. And then what I want to do is I want to return, so I'm going to do a parameter called distance. Okay. So what I'm going to return is that math function we were talking about. So distance divided by pi times the diameter. So here's the distance. Let's do some math. So divided by, okay. And I'm just going to pick a number, but that's not what I want. I want 3.14 because, by the way, pi is not part of Alice, so you have to type it in. I had already typed it in, so it's 3.14. It's 3.14 times the circumference, but we said that was really times the width. So I'm just going to stick in a number right here. I go down to toy ball. I get the toy ball's width because that's the same as the diameter, and I throw it in, and we are ready to go. And you'll look and it's exactly the same as that. Okay? And it just gets called. So one more time, it's rolling and it's all good. And you could play around with changing the distance. So if I want to change it to, I don't know, 1 meter, and if I change this number to 1 meter, watch what happens. It's a much slower roll, but it's the same idea. Okay, so the concepts illustrated is that a function must have a return statement because it's got to send something back. If you go to back to that black box analogy, something's got to come out, otherwise what's the point? We used a math expression to compute the number of revolutions, and we talked about the parentheses, and that we've done over and over, so I'm not that worried about that. And you saw that to calling the function, oh, maybe I should go back and show you on that. But first of all, you call it by dragging it in, and also you're going to test different numbers. We talked about this in class. Test numbers that make sense and figure out what happens if you would use a negative number. So let's play with that for a second. Okay, so let me show you how to write a method and call a function. It's pretty easy. So I'm going to drag toy ball turn, and we're going to have it turn forward. And when you go to expressions, that's where the functions show right up. So you don't even have to drag it in. It just shows it right like that. And if you want to make duration 2 seconds, and like we talked about, you can change these numbers. Okay, I want to undo that because what I want to do is let's try some numbers for parameters that are not good numbers. So let's try -1. And maybe we'll make this -1. Let's see what happens. Oh, that's kind of cool. It goes backwards. Okay, so that works. It just does it differently than maybe you had expected. All right, which makes sense. Okay, this is the last slide. I just want to finish up with what kinds of functions we have. So they can be either object level or world level. We were just dealing with object level because I clicked on toy ball. And the guidelines that for our methods apply to functions. No references to other objects, no references to world level functions you've written. Built-in world level functions are fine to use. And that's it. You made it. All right, enjoy. Go create some functions.